Tried practice 3.38, so let's see how you did. So we get an airplane pilot who wishes to fly due west. A wind of 80 kilometers per hour is blowing due south, and if the airspeed of the plane in still air is 320 kilometers per hour, in what direction should the pilot head? And what is the speed of the plane over the ground? Okay, so we have a couple questions to answer. What is the direction the plane should fly? And how fast is it actually moving? So we want them to fly west. There's a wind south, and we know we're flying at this speed, but we don't know what direction to fly. Well, if the wind is trying to blow you south, so if I'm trying to fly west and the wind's blowing me south, I'm actually flying kind of southwest. So to counter the wind, I'm gonna have to fly a little bit north, so that as I fly, I end up kind of flying west. The northern component of my velocity cancels out the wind, and my western component of my velocity is what I'm moving at. So this is my 320 kilometers per hour at some angle theta. I need to fly northwest in order to counter the wind. Now, some of you might be able to look at this picture and even come up with the idea, well, this component better be 80. This is 320. Not going to take much but trigonometry to figure out those other parts. But let's say this isn't a nice 90-degree triangle for you here. Let's assume that maybe I'm not flying, isn't perfectly south and west. And so we'll have to mess around a little bit more with it. Okay, so here we go. So the first thing we're going to know is we're going to be moving at some x component, I'll call it, in the west direction. So it's negative I hat plus 0 j hat. I don't want to be moving north or south in the end. The wind, on the other hand, is not moving in the I hat direction, but it is moving at negative 80 in the j hat direction. And down here, I will need to imagine resolving this into those components. So I have a negative 320 cosine of some angle theta, which I don't know, but I'm trying to find it, I hat, plus 320 sine theta j hat. Now, the advantage here is, just like we did on that other problem, where I can use this equation in the j hat direction and I can use it in the I hat direction. So in the j hat direction, I have 0 is equal to 80 plus 320 sine theta. What I can use this for is to find theta. So if I go ahead and solve for theta there, we end up with 14.5 degrees. So now I know my plane should be flying at 14.5 degrees north of west. They also asked me to find how fast I was moving. So now I can go over here and I say, well, negative Vx is equal to 0 plus negative 320 cosine of theta, which was 14.5. The negatives cancel, and so I find out that the x component, how fast I'm actually flying west, is about 309.8, maybe I'll write that, 309.8 kilometers per hour. So some of that 320 is going into countering the wind, the rest of it is going into moving me westward. So there you go.